Okay, welcome back. So what you guys have already done is start to understand the goal of this week, which is going to be counting colony-forming units on some simulated plates of bacteria. And what I want to show you now is how you're going to be recording those data as you are collecting them. And so there's some basics to entering data into a spreadsheet that kind of transcends fields and are just some kind of nice practices that will help ensure that your data is nice and flexible, can be used for a bunch of downstream applications, and are easily understandable by people other than yourself. Because many times in science, we are handing things off to other people as we graduate, or we move on to other projects, or maybe we have collaborators, or our research is funded by taxpayers, and so eventually everyone will have access to the data. So these are kind of important things to do right the first time, so you don't have to go back and redo everything down the road. So the first thing, if we're looking at a spreadsheet, and Excel is kind of the most common format for spreadsheets that probably all of you are familiar with. And so Excel is comprised of kind of a series of columns and a series of rows. Columns are typically letters, rows are typically numbers. Now, what we want to do is take these columns and we want to give them headers or names for whatever are going to go underneath them. And I always start on the second column or further off because eventually we're going to have kind of observation names here, and that'll make sense in a little bit. And so think about all the possible different variables, things that you're measuring, whether it's temperature or weight or number of colony forming units on a plate. Think of all the different things that you can measure or might be informative related to your measurements, and make a column for each one. So if we're thinking about microbiology and counting colony forming units, well, maybe the date that the plates were made. So the date that the bacteria were spread onto the plate. Maybe the date that you counted it. That might be useful to know. Maybe it was really cold that day or something and you were shivering and didn't count very well. That might be something helpful to figure out down the road. Maybe treatment. Maybe we were looking at different isolates or different species or the same species, but we treated one with antibiotics and one not with antibiotics. You know, it could be anything, but that might be important to know. If we're isolating these from a living organism or something before they're being plated, you know, we might want to keep track of what mouse they were isolated from. These are all important things, and we haven't even got to what was counted yet. In the previous video, we talked about how certain numbers of colony-forming units are ideal. You want them to be within a countable range. And if we pull out a plate and we go, hey, it's not countable, well, it might be useful to keep track of that. Was it countable or not? Could be one of our values. And then finally, the thing that you probably originally were thinking would be the first thing in the spreadsheet, which is colony-forming units. How many colony-forming units were on the plate? What about what was the volume plated? So of all the bacterial culture that was put on the plate, was it a milliliter? Was it 5 milliliters? Was it 10? Was it 0.1? These are important things to keep track of. And how diluted was it? What was the dilution? And so these are kind of, in my mind, kind of really critical things to keep track of as you're counting for an experiment like this. And I've left one thing off here, and that's going to be our individual plates. And so maybe plate ID would be the next thing that you put on there. And so we're going to go in and we would fill in a row for each one of our observations. And before I show you how to do that, I want to point out a few other things here. One is to avoid combining pieces of information. Always split things as much as possible. So, for example, here I've split up the mouse that it was cultured in, as well as the treatment type. It's always good to separate these things out. You wouldn't want to say like antibiotic mouse named Chaz or something as one column. It'd be better to say, hey, this mouse name is Chaz, and it was treated with antibiotics. Because you might want to split out Chaz at some point, or you might want to split out all the antibiotics, and having them in one single column makes that more difficult down the road. Units. Units are always very important. I like to put units, and most people like to put units in the column header. So volume plated in milliliters right here. That way, as you go through and you put down volume plated below this, you're not having to put milliliters in every single cell. Not only that, if you put the units in there, it can mess up some of your formulas later. Now, the other thing I'll mention here is you see me doing a lot of underscores. This is on the border of personal preference. This is not something everybody does or is required for all purposes. But spaces between things can cause a lot of problems for certain applications, particularly when you're importing things into R or doing big data analysis. And so my personal recommendation is, if it doesn't drive you absolutely insane, use underscores instead of spaces. It's not the end of the world if you don't either, but just know that that is one possible source of problems depending on what you do with your data set later on. Okay, so we've got all of our column headers. Now, what we want to do, and maybe it helps you to make these bold or something, doesn't really matter. What we want to do now is, as we count our colony forming units, we want to record all the pertinent information in here. And each observation or each data point is going to be an entire row. We're not just going to go in and fill up all the CFUs. We're going to fill in all the pertinent information. Maybe we looked at a plate and it was called 1 alpha 2. And we plated it on 12 July 19. And we counted it on 13 July 19. And this maybe was our unknown 1. And it was from our mouse named Chaz1. And if we look at it, maybe we see that there's 50 colony forming units or so. It's within that good countable range. So we would say, yes, it's countable. And we counted 55 colony forming units. When it was plated with 0.1 milliliters. And it was a dilution of 10 to the 4th. And so in Excel, the way we would enter, normally you're going to see it written as 10 to the 4th, but Excel doesn't necessarily like that. Equals 10 to the 4th, and hit enter. And so now we've got it there. The last thing that you might want to put for any one of your observations are things that don't fit squarely into the variables or measurements that you're making. I always like to have a comments tab, and you can bold that as well if you want. And this is for, anything that might be important, but you're not sure if it's something you're going to collect for every piece of data. I mean, it could be that Chaz bit me, and I don't know, it might be good to know that in case down the road you realize this unknown 1 is incredibly pathogenic or something. So I like to use comments for that purpose. And then you would just go down. Okay, we're going to count the next one to beta 8. Maybe it was plated on the same day, 12 July 19. And, you kind of see where I'm going with this as I'm filling it out. And so I will show you a couple little tricks. If you want to just bring down your dates, you can click and drag. And if I want to just copy this 13 July 19 further down, you can hit Control-D. We could even go even further, all the way down here, and hit Control-D. So, or if you go too far, you can hit Control-Z to undo. These are all kind of basic word processing shortcuts that are applicable in spreadsheets as well. And we'll finish filling this out with just one more row, or 2, unknown 2, Chaz 2. It was not countable. If it's not countable, this is, we wouldn't have a countable number, because if there were, let's say it looked like there were thousands of colony forming units, we're not going to count it. And we're going to say, hey, it's not countable. But we don't want to leave things blank in our spreadsheets. That's another important kind of fundamental aspect of spreadsheet entry. Don't leave blanks when you can. Put zeros where applicable, And where they aren't applicable, you can put something like not applicable. Or in the case of this, we're not counting them because they're too numerous to count. So maybe you abbreviate too numerous to count as TNC. Just so later you can sort and pull those things out. Even though we didn't count it, it still had a dilution value and volume plated. Maybe it was 10 to the 5th, though. And we'll do one more row. So 8Z5. Our dates are the same, so we'll control those down. We'll say this was unknown 1 again. And this time it was Fred. And not countable TNC, 0.1. And it was the same as the first one, or the second one. And so now we've kind of got a little data set where we can see lots of important values. We can see our individual pieces of information for all of our observations. We've made sure not to leave anything blank, trying to make it as informative as possible. Other things to keep in mind as you're doing this. Once we have what we would call this raw data, we haven't analyzed this yet. This is really kind of the raw input. Don't ever mess with this. Once we have this whole data set, leave it alone. Don't go through here and start tweaking things or multiplying them or trying to do your math here. Think of this as just a permanent representation of the output of your experiment. And if you want to mess with this or some part of this, all you have to do is cut and paste whatever parts are useful, and you can make a new spreadsheet, or you could make a new tab by clicking the plus button down here and paste them in here. And now you can start messing with this, and you've preserved the integrity of your original raw data. So that's kind of a very important thing to do, is always keep one original raw data copy. The only modification to kind of your raw data that you might potentially consider making is just for your own kind of personal preference. Some people like to use formatting to make things easier to look at. You're not changing the values of the information in any way. And so that's totally okay. Maybe you want to color the rows based on what the treatment is. So here we've got unknown 1 and unknown 1. Maybe we want to make those rows the same color. So we could select both of those rows by control clicking on them. And then maybe we want to say, hey, these will be light green, and our unknown 2s will be light blue. This doesn't change the raw data in any way. This might just make it easier for you to look at. And if that's something that helps you, by all means, please do that. And so that is, in a nutshell, kind of the very basics of data entry and some basic principles to kind of make it so you're not going back and having to repeat things that you've done multiple times. So if you kind of adhere to these kind of guidelines loosely, you'll save yourself a lot of time and effort in the long run.